Hello again, YouTube. This is John. Welcome to part 2 of this video series of past projects that I've completed. This one here, I think there's like a quench tank that I've worked on, a couple plop grinder projects that I was involved in. There was a bobcat repair in there and some other little things. So anyway, sit back and enjoy. This is a quench tank that I built. Now, again, I didn't fabricate the entire thing. We had another machine shop, local machine shop that had a big press brake and big shear that was able to cut and bend these sections for us. I think there was three sections. I want to say 10 foot long. Yeah, 3 sections 10 foot because it was 30 foot long. And I added in these stiffener bars right here. I think I put them like every 18 inches, I think, maybe. But these were to keep it from bowing out that way, is what those were for. And I added in this piece of 2-inch angle right here also. Of course, put them in before I put these in. And I built this frame, down here, and put it on wheels. This thing had to move out of the way. For changing processes on the line. Let's see if I can just undo that. Yeah, ooh, neat. There we go. But I built everything except for the actual bent sections. Then I had to weld those together. And I believe the way I did it is I think I lap welded them. I think I had to make the center section slightly oversized than the 2 end sections, so I was able to put it together and then lap weld them together. And there's the back side of it. The strands would come in this side and run down the length and then out into the cutter. And I put these pipe fittings in. I had to weld in bungs for all that. And there's a kind of a artsy shot down the middle of it, all stainless. I think that was what was it? That's 16 gauge, 18 gauge, 16 gauge, 16 gauge stainless. TIG welded, all TIG weld together. Actually, no, I didn't TIG weld most of this. I think I TIG welded like the fittings and stuff like that, but most of this I MIG welded together. Because right there was my little dual voltage Lincoln 210. I love that little machine. And I used it to MIG weld it together. Used I think 316 stainless 316 rod or wire, 035 I believe, with Trimix. I believe I used on it. Yeah, Trimix works well for stainless. It was I want to say like 90% argon, 2%, 90% argon, 8% CO2, 2% oxygen, I believe was what the Trimix was that I'd use. And there's the whole thing put together. I put this pump here on it. We put this pump here, discharged out from here down through to a clean out, a little Y clean out, into the pump, into a heat exchanger, out of the heat exchanger, back into the tank. So the water flowed this way in this thing. It was self-contained. You just recirculated the same water. And to keep it cool, this heat exchanger was attached to a chiller unit. Actually, it was attached to the cooling towers outside first, and then we put a chiller unit on it. And it was basically just a radiator is all it was. But instead of using air and water, it used colder water to cool the processed water down with. There's a broken tap. That's a crappy day. Anytime you break a tap is a crappy day. And anytime you got to bring out a 7-inch metal case Wildcat grinder is a crappy day. I don't even remember what I was doing here. I was grinding this down, but I can't remember what it was for. It was some kind of flange for something. I was working on that quench tank at the same time, though. You can see it in the background, and I actually had to try to protect the end of it here from the sparks from this. That's one thing you guys should remember on stainless. If you've got something stainless that you're working on, especially if it's something that has to be nice, and either you or somebody else is grinding steel, try to not hit the stainless with the sparks from the steel, because it will actually embed that steel into the stainless, and then your stainless will rust. I've seen it happen. And I've actually worked in a shop that we had to scrap an entire project, an entire frame that we had built because somebody had come in and worked on something during the off hours, in the evening, and just showered it with sparks. And we came in, like it was almost like the weekend. We came in the following Monday, and here's this thing that we had just pretty much got 80% completed, and now it's rusted to hell. Oh yeah, that's what I was building. This was a discharge chute for a new plop grinder that we put in. Well, when I say new, I mean it was new to us. It was still old and used and about half wore out when we got it. This was let's see, what was this? This was, I think, 3/8 on the sides, 1/4 inch on the bottom. This was 3/8 thick, I want to say 8-inch diameter pipe on it. I'm sure there's other pictures of it. Okay, yeah, there's where it goes. There's where it went right here. Man, I'm missing my little drawing thingy. Okay, but yeah, there's where it went there. It went on the bottom of this big grinder right here. And this thing here was a beast. This thing was mean. You'd have these giant plops, is what we called them. There's just basically giant blobs of melted plastic that would come out of the extruders. When something messed up, when they couldn't get the strands running, they would just out of the end of the extruder, and then they'd cool them down. And then, of course, we would take these plops and we would grind them back down. After they cooled down and everything, we'd grind them back down and then run them back through the machine, to negate waste. And this thing, it was basically a giant ass wood chipper, is what they are. The plops go in the top and small bits come out the bottom. And you got a screen in there, of a certain size, to control the size that they would come out. And there it is. Yeah, so when we got this thing and we installed it in the area that the old plop grinder was in, this thing was about almost twice the size. So of course, bigger electric we had to run to it. It was missing parts when we got it, that I had to fabricate. I had to fabricate this guard over here on it. Um, yeah, I had to fabricate this belt guard over here because that's what, or no, it was a chain. Was it chain or belt? Belt. Yeah, it was belt. Run off like I think like five big V belts, and I can't remember the motor size on it, but it was big. I remember we had to run no electric to it, 480 volt, of course, and but yeah, I had to fabricate this. I had to build that because the chute that was on it wouldn't work with the rest of our system. Uh, well, I done a lot of work to this thing. This was like a 3 4 week project of putting this in, and of course they're screaming the entire time. They want it now, 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 now. This thing, it has to run right now, and well, what can you do? It all takes time to do and to do right. So don't know what to tell you. Yeah, so there's the back side of this. Discharge chute comes out. Actually had a blower on the back side over here that would actually suck this material out of here and blow it up into a cyclone that would then drop it down into a box. And there's another picture of the guard. I think I made this guard in like 4 pieces is what I had to make it in. And even making it into 4 pieces, it was still a bear. It was like a 2-man job to get this stupid guard off here. And luckily it didn't have to come off very often. Only when you was changing the belts or servicing the belts. But yeah, it was a bear to get off. This thing was a bear to get off too. I think I was heavy, man. That thing weighed, at least a couple 100 pounds, I'm sure. And yeah, there's just more pictures with close-up pictures. Okay, this is the table. This is the table that went with this thing. Uh, luckily some of my pictures have been grouped together with the project that they went to. They ain't totally spread out on this thumb drive. And again, there's the quench tank back here in the background that I was still working on when I was working on this. They would just prioritize stuff on me. I'd start on a big project like this, then oh no, we need this now. And so this was a table that went on the in-feed conveyor to that grinder. And I think I got pictures of the in-feed conveyor. Anyway, they would dump the plastic plops onto this just to kind of spread them out and then shove them onto the table. But I think 3/4 inch plate. These were 1/4 inch diamond plate sides that was kind of flared out like that. It had to be heavy because that plastic, it would just, they would take a Bobcat most generally. Well, they had a box dumper. They had a dumper that sat behind here. But they would just generally take a Bobcat with a bucket and scoop these things up, bring them up, and just, from 6 feet above it, and just poof, dump it on this table. And it beat the shit out of it. The old one, it had probably a dish in it that freaking deep. Okay, this is the conveyor that went with the grinder there I was just talking about. This is the table, the back side of that table that I was just talking about. This was actually the first conveyor. This pissed me off right here, right? They sent this conveyor with this machine, and it was not the right conveyor that it needed. Number one, it was way too short. It was set, by the time we got it up to where it had to be, of course, this height is set by the plop grinder, this height was set by the table, which in turn was set by the box dumper on the back side. So you couldn't really vary it that much. I mean, maybe like 6-8 inches at the most. I could have raised this up, but this thing was at an extreme angle, and so these things would go up and they would just fall back down most of the time, and it run way too fast. We did gear it down, with changing different sprocket sizes. We did gear it down, but it's still way too fast. It was the wrong conveyor. We told them it was wrong conveyor. They still wanted to use it. So I spent like I don't know, a couple days building this thing up, putting a frame underneath of it to get it raised up, and then they figured out it was the wrong conveyor, like we'd been telling them. So I used this conveyor, which was the old conveyor from the old grinder, which was much longer, much wider, and was able to get a much shallower angle up into it. But of course, it was this thing here was like, I think like 5 feet higher than what it was initially supposed to be, or what it initially was. So of course I had to raise everything up, add in legs, add in bracing, move it back into place, and I got this done. I think it took. They wanted, of course, they was wanting this thing right now. I think I put this conveyor in like 2 days by myself mostly. I think I had one guy helping me for like half of one day, and that it worked. It worked. It was the one they should have used the first time. What is this? Oh, this was we called them a strand vac. This one on the end of that quench tank. The strands would, kind of run through these, over this one, under this one, over this one, under this one, over this one, under this one, and it was hooked to a big blower that would actually create like a vacuum and suck the water off from the strands. And let's see, what did I do here? I think we had this box, we had this part of it, and I think I had to actually fabricate these pipes, which were just like a 2-inch galvanized pipe that I put on the mill and milled a slot down, and then capped the ends, to create a suction. Let's see. All these were. This was a constant battle inside that place. These were drain covers, and the old ones that they had, they were way too light. They had been there for probably 30, 40 years. So, whenever I'd have to replace a section of them, I'd just take 3/4 plate and, burn out these holes in it, cut it to the size, torch cut it to the size, burn out these holes in it and lay them down in there. And they were heavier than hell. I mean, it's 3/4 inch plate, probably 12 inches wide, 48 inches long. But you could run forklifts and equipment over them, and you wouldn't dent them in and damage them. What is this? This is a bushing that I made for something. I don't remember what it was. I don't know. Some kind of bushing that I had to turn out on the lathe. Oh, that's what it was for. Yeah. Yeah, that's what it was for. This was our Bobcat. Yeah, this ancient relic here. Man, this thing was dangerous. God, this thing was dangerous. I'd seen young guys that had no business being on a Bobcat, that had never really run one, didn't have much training on one. They'd give them a couple hours training, throw them on this thing. Man, this thing was, for one, it had the old sticks on it. It didn't have joysticks. It had the old sticks with the foot pedals on it. And you'd start it up, no neutrals on this thing at all. You'd start it up, and if that, if the sticks were were engaged when you started, it started doing circles on you. And man, I seen, oh, it wasn't funny, but it was funny. I mean, it was like being on a rodeo horse or something. But anyway, they broke they broke the pin out of it, and the whole bucket and everything just kind of swung out on the guy, and he drove it into my shop, with the arm raised up and the bucket just swinging, and he's like, I was told to come see you that you might be able to fix this. And yeah, I did. So I think I've got other pictures here of it. Yeah, here you go. So basically all I did was I don't know, I cut some angle and blew holes in it, and I think that right there was the bushing that I'd machined off, and put the pin back in. Luckily the pin wasn't damaged. It wasn't bent, or I didn't have to fabricate or try to source a new one. So yeah, I just welded some angle in it, made a new bushing, put it back together. Got it working again, sent them on their way. This was another grinder. This one wasn't at our facility. This was at another facility. That was, I don't really know how to explain it. At that facility, they didn't do an extrusion process, but they did like secondary processes, boxing, packing, sorting, classifying, and stuff like that. And this was their plop grinder that they would, they'd get these plops from other facilities that were tied to us, and they would process them there and then send them actually to us, send the boxes of regrind to us. And this one was set up different than ours. It had this giant rotor in it that had these carbide teeth that would set on top of these little ledges here, and of course it'd get wore down. Like I said, man, that plastic was rough on stuff. It'd eat stuff down. But anyway, so they didn't have a fabricator there. They had a couple maintenance guys, and one of them could weld, but he wasn't comfortable with doing this. So they'd send me up there every year, to work on this thing, and I'd have to cut these off and weld on new ones. And I mean, it's fairly simple, it wasn't a whole lot to it, but he just didn't feel comfortable with doing it. And I mean, I understand that this thing spun at like, God, I don't know, something like 17,000 RPM, I want to say, or something. I mean, it was a wicked speed. But yeah, so that was the process. Is you'd take a cutoff wheel on a grinder, and you'd slice down the sides of these, and then I'd take a punch, using a punch handle, of course, and drive down into them and break them off. And then there is the new one. I would tack it in place and then put one of these new teeth on it, just temporarily put it on there and make sure it was lined up. So I would spin it and make sure it had clearance. And there was a measurement for this. I can't remember what it was, how many thousandths it was. It was big enough that you could just eyeball it. I wouldn't check every one of them with a feeler's gauge. You could just kind of look at it and see. It was something like 100 thousandths or something like that, almost an eighth of an inch or something. But anyway, you'd spin it to make sure it wasn't binding up and clearing up, and then I'd spin it back around. I've done this with MIG, ER70, 7525 gas, 035 wire probably. But anyway, I would run an uphill preheat. I would preheat it. I remember that. I'd take a torch and preheat it to a temperature. They actually had a WPS on this process that I had to follow. And but anyway, I'd run a vertical up and then a vertical down to just kind of clean it up and fill it in, and then take a wire wheel, buff it down, and go on to the next one. I think I can't remember how many was on this thing. It was a lot, and I think I could usually get about, I don't know, about 14 of them a day, I think. So I'd usually do a couple days worth, so that was like 28. And then they would, their mechanics would actually bolt them on and torque them down and everything like that. So it was a good thing to get me out of the shop for a couple days once in a while. This was some kind of setup that I had going on. Oh, this was a heater plate that had like rod heaters that would run through it. It was aluminum, and let's see, did I make that? I don't think I made the plate. I think it was something they had bought, but it had the wrong diameter in it, and they wanted me to drill it out, and the stinking thing was like, I don't know, like 14, 16 inches long. And I ain't got a freaking drill press big enough. I ain't got a radial arm drill or anything to drill a 16-inch deep hole in. So the solution was to actually fabricate a bit. I think this was like a 5/8 diameter drill. Was actually to fabricate this bit, weld a rod to a drill bit, chuck it into the lathe, build this rig, put this piece of plate on my slide carriage. I think I had to shim up the bottom. I think I've got it was pretty close. I remember that it was real close, but I did have to shim up and level and square everything up through here, and then run the drill bit in the chuck, and then use my my carriage feed to feed into the drill. And I mean, at the time it was sketchy, but it seemed sketchy to me anyway, but it worked slick. It worked pretty good, actually. This was more pipe. This was more more abrasion wear. They'd have anywhere these pipes would change directions, would go to a 90, and they put there'd be a long sweep 90 on it, and it would wear them out. It'd eat them out, and they'd bring them down, and I could usually patch them once, depending on what it was, depending on what they was running through it, because there was contamination issues. Some of this stuff you couldn't mix with the other stuff because it would contaminate it and ruin the whole batch worth. And so this was like just a last chance band-aid is what this was. And I'd slap a piece of sheet metal over top of it and weld it up and put it back in, and once if they run the same material, it could stay, but if they tried to run other material, no, it had to come out. There's another one. Just eat through it, man. This stuff would be paper thin and razor sharp. What was this? This was a fitting that I made for a Cyclone, I believe, on a machine they had that was some kind of dust extractor machine or something like that they had. But it had worn out. I think originally it was made out of aluminum, and of course that didn't last very long at all. And so I fabricated this out of this was steel and stainless. This part was steel, this part was stainless. And I remember that I didn't have a piece of round stock big enough, and I don't think I got pictures of it, but I didn't have a piece of round stock big enough to machine this out of. So I machined it out of a piece of square that I had. I had a big square block that had come off from some machine, and I actually cut it into like like an octagon shape, on the bandsaw, and then put it in the lathe and made it a round, and and cut the threads and knurled it and center bored it, and then welded this pipe into it. There it is. There's the other view. This is a piece of stainless pipe, and went through and welded onto the back side. But yeah, I was actually kind of proud of that one. Yeah, I was actually, hey, if I ain't got a piece of round big enough, I got a piece of square big enough. I got a lathe, I can make square stuff round, no problem. Yeah, there was the old piece that was in it. Another bolt extraction. This was in a gearbox shaft that they had, and yeah, they had a mechanic that worked on this thing for like, I don't know, like 2 days, trying to get this bolt out. And like I said, it was a gearbox, some kind of gearbox shaft. And he finally, I don't know if he gave up on it or they told him, said, look, we're tired of you messing with it. Just, take it to John, see if he can do it. And, so he brought it down, and I think I had this thing out in like, I mean, I felt bad for the guy. He had messed with this thing for 2 days. I had this thing out in like an hour maybe, and I had welded a nut to it again. Always first thing, just try to weld a nut to them. And I believe it was left-handed thread is what it was. I can't. Let's see. Yeah. Looking at the bolt, that is left-handed thread, and yeah, that's why he couldn't get it out, as he was trying to turn it the wrong way. So yeah, I just backed it right out, and I felt bad for him, really. This bent pigtail screw from one of the big feeders that we had. They jam them things up and bend them all the time. And these things were nasty. They'd always bring them to me. They were nasty. They were covered in black graphite crap, and I didn't have a power washer or a Hotsie or anything like that, so it was just use brake parts cleaner mostly just to clean them off with, and rags, and they were just nasty to mess with. I hated them. Well, what were these? These were some kind of rods I was making or something. That ain't more of it. I think these were like some kind of support rods for that conveyor that went on the grinder. I think these were support bars that I'd had to put up in there. And I think I used like 2-inch pipe, and I orange peeled. I cut orange peels and orange peeled them over, and welded them up, and then buffed them down, so they wouldn't catch and rub. That was pretty easy. And this was a rig I made up for the lathe. This was actually my tool post grinder for the lathe. That's what this was, which was just a tool post that went on my quick change, and and I just put a rod in the end of a 4-inch Metabo grinder, and I could run the grinder and run it into shafts and stuff, and kind of polish a shaft, get a finer finish on a shaft on the lathe. Poor ways to do stuff sometimes. There's some little table that I built for one of the areas, one of the lines. They wanted their own vise and their own bench grinder, and they wanted it, bolted to a little work table. So yeah, there you go. This was nothing to do with work. This was, or at that job anyway, this was work. This is actually my uncle's dump truck that the frame needed a repair on it. So I mean, it's a dump truck, and this, before I catch hell from, because I know somebody, if anybody watches my videos, is, oh, don't weld on the frame of truck. Look, it depends. Here's my rule for welding on frames of vehicles. One, I got to know the person, and I got to know their intentions on the truck, on the vehicle. If you're just wanting a patch job to pass it off onto somebody, you can get the hell out of here. I don't want nothing to do with it. But if it's, if I know the person, know their intentions, know what they're doing with it, I will do it. I have done it. I've done many of them. I don't like to do them, but we do what we got to do. This was, I mean, that was, I think, 1/4-inch steel that we had bent and cut and plated it in. I rounded the corners. There's no stress risers in it. I've rooted and then MIG'd everything in it. I mean, it's stronger than the original, and it's on a damn dump truck. So thank you for watching part 2 of this video series. We've got I think one more part. I'm going to try to do it in 3 parts. Both of them probably about 30 minutes or so. Anyway, like, subscribe, comment, all that good stuff that everybody says in every one of their YouTube videos. And we'll catch you on the next one.